The world is on the brink of a clean energy revolution. This transformation is not just a possibility, it is a necessity for the future of our planet. Fossil fuels have powered our industries and transportation for over a century. They have been the backbone of our economic growth and technological advancements. However, their impact on the environment is undeniable. The air we breathe is filled with pollutants, and our cities are often shrouded in smog. Harmful emissions pollute our air and contribute to climate change. The melting of glaciers, rising sea levels, and extreme weather events are all symptoms of a planet in distress. We need a sustainable alternative, and hydrogen fuel cell technology offers a promising solution. This technology has the potential to revolutionize the way we think about energy and transportation. Imagine a car that emits only water vapor from its tailpipe. No more harmful gases, just pure, clean water. This is the promise of hydrogen fuel cell engines. They offer a vision of a future where our vehicles are not a source of pollution, but a part of the solution. These engines produce electricity through a chemical reaction between hydrogen and oxygen. This process is efficient and clean, providing a reliable source of power without the drawbacks of traditional combustion engines. Unlike gasoline engines, there is no combustion, meaning no harmful emissions. This makes hydrogen fuel cells an environmentally friendly alternative. Hydrogen fuel cell technology is not limited to cars. It can be applied to a wide range of vehicles, including buses, trucks, and even trains. Buses, trucks, and even trains can be powered by hydrogen. This versatility makes hydrogen fuel cells a key player in the transition to clean energy. As we move towards a cleaner future, understanding how this technology works is crucial. Education and research are essential to advancing hydrogen fuel cell technology and making it accessible to all. Let's delve into the fascinating process of energy generation in a hydrogen fuel cell engine. By exploring the science behind this technology, we can better appreciate its potential to transform our world. The journey of energy in a hydrogen fuel cell engine begins with hydrogen gas. This gas is the lightest and most abundant element in the universe, making it a prime candidate for clean energy. This gas is stored in a pressurized tank, much like the gasoline tank in a conventional car. However, unlike gasoline, hydrogen is stored at very high pressures, often up to 700 bar, to ensure enough fuel is available for long journeys. From the tank, hydrogen travels to the heart of the engine, the fuel cell stack. This journey is crucial as it marks the beginning of the energy conversion process. This stack is where the magic happens. Here, hydrogen's potential energy is transformed into electrical energy, which powers the vehicle. The fuel cell stack is made up of several individual fuel cells. Each of these cells works in unison to generate the required power. Each cell consists of two electrodes, an anode and a cathode. These electrodes play a pivotal role in the electrochemical reaction. The hydrogen gas enters the anode side of the fuel cell. Here, it is split into protons and electrons through a catalyst. Meanwhile, oxygen from the air is fed to the cathode side. This oxygen is typically drawn from the ambient air, making the process efficient and sustainable. These two gases are now separated by a special membrane called the electrolyte. This membrane allows only the protons to pass through, while the electrons are forced to travel through an external circuit, creating an electric current that powers the vehicle. Oxygen plays a crucial role in the operation of a hydrogen fuel cell engine. Air, which contains oxygen, is drawn into the fuel cell system. This air is filtered to remove any impurities before reaching the cathode side of the fuel cell. The oxygen's purpose is to react with the hydrogen. However, this reaction doesn't happen directly. The electrolyte membrane between the anode and cathode acts as a barrier and a facilitator. It only allows specific ions to pass through, setting the stage for the electrochemical reaction. The real magic happens within the fuel cell. At the anode, hydrogen gas encounters a catalyst. This catalyst, often made of platinum, facilitates a remarkable process. It splits the hydrogen gas into protons, which are positively charged hydrogen ions, and electrons, which are negatively charged particles. The electrolyte membrane is the gatekeeper between the anode and cathode. It allows the protons to pass through but blocks the electrons. These electrons are forced to take an external path, creating an electrical current. This is the electricity that will ultimately power the vehicle. Section 5. Powering up, from electrons to motion. The electrons, separated from the protons, travel through an external circuit. This circuit forms the electrical pathway that powers the vehicle's motor. As electrons flow through the circuit, they generate the electricity needed to drive the car. At the cathode, the protons that cross the electrolyte finally meet the electrons that travel through the circuit. They also encounter the oxygen waiting on the cathode side. These three components combine, forming water, the only byproduct of this process. Section 6. Clean exhaust, water vapor, and heat. The exhaust from a hydrogen fuel cell engine is remarkably clean. Remember the water formed at the cathode? That water, along with some heat generated during the reaction, is expelled from the fuel cell system. Unlike the harmful emissions from gasoline engines, the exhaust from a hydrogen fuel cell engine is primarily water vapor. This makes it a zero-emission vehicle, contributing significantly to a cleaner environment. The small amount of heat generated is also harnessed to further improve the efficiency of the system. Section 7. The promise of hydrogen, a brighter future. Hydrogen fuel cell technology offers a compelling alternative to fossil fuels. The benefits are numerous and far-reaching. First and foremost is the environmental advantage. Zero harmful emissions mean cleaner air and a significant reduction in greenhouse gases. Beyond the environmental benefits, hydrogen fuel cells offer high energy efficiency. They convert a higher percentage of fuel into usable energy compared to traditional combustion engines. This efficiency translates to reduced fuel consumption and lower operating costs. Other benefits include quieter operation, enhancing driving comfort. Section 8. Challenges on the road to a hydrogen society. Despite the immense promise of hydrogen fuel cell technology, challenges remain. These challenges are multifaceted, involving technological, economic, and infrastructural aspects that need to be addressed for hydrogen to become a mainstream energy source. One of the most significant hurdles is the development of a robust hydrogen infrastructure. This includes the construction of hydrogen fueling stations, which are currently sparse and concentrated in specific regions. Widespread adoption of fuel cell vehicles requires a network of hydrogen fueling stations. Unlike gasoline stations, hydrogen stations are not yet ubiquitous, making long-distance travel in hydrogen-powered vehicles challenging. The cost of producing hydrogen is another challenge. Current methods of hydrogen production, such as steam methane reforming and electrolysis, are expensive and energy-intensive. While hydrogen is the most abundant element in the universe, it requires energy to extract it from sources like water. Electrolysis, which splits water into hydrogen and oxygen, is a promising method but needs to be powered by renewable energy to be truly sustainable. Making this production process cost-effective is crucial for the technology's success. Innovations in renewable energy and advancements in electrolysis technology are essential to reduce costs and improve efficiency. Additionally, storing and transporting hydrogen safely and efficiently pose logistical challenges that need to be addressed. Hydrogen is a highly flammable gas, requiring specialized storage tanks and transportation methods to ensure safety. Developing advanced storage solutions and a comprehensive transportation network is vital for the future of hydrogen energy. Overcoming these challenges will pave the way for a sustainable hydrogen society, transforming our energy landscape. Section 9. Hydrogen fuel cells, a sustainable solution for tomorrow. Hydrogen fuel cell technology holds immense potential to revolutionize our world. While challenges exist, the benefits of clean energy, high efficiency, and reduced emissions are undeniable. Overcoming the hurdles of infrastructure development and production costs is key to unlocking a sustainable future. As research and development continue, we can expect to see improvements in fuel cell technology, making it even more efficient and affordable. Embracing this clean energy solution is a step towards a healthier planet and a brighter future for generations to come. If you enjoyed this video, please like, share, and subscribe for more content on clean energy solutions.